Good day, Mrs. Tole here. So today we are looking at, we're just going to look on the solution for linear functions. And in this type of equation, you need to first make y subject to the formula. So we're going to take y to the left. So when it crosses the equal sign, it changes the sign. So it's going to be positive. Then we take the 4 that side. It's going to be 5x minus 4. So now our equation is in the form of y is equal to mx plus c, which is the standard form. Then from there, we need to find the intercepts where the graph is cutting the x and y axis. So for y axis, y-intercept, x must be equal to 0. So here, if we put, it's going to be 5. Then we have 0 minus 4. So our y-intercept is negative 4. So we know that this is going to be 0, negative 4. Then our x-intercept, we are making x subject to the formula and y is 0. So here x-intercept, y is equal to 0. Then in this case, we're going to have 0 is equal to 5x minus 4. Then we take the 4 the other side. It's going to be 4 is equal to 5x. Divided by 5, we get the root of the 5. So here, our x is going to be equals to 4 over 5. Okay. Now, so when we are sketching for linear functions, we just need to connect the intercept, the y, x, and y. So here, let's draw our graph. There's going to be our x, our y, our origin. Then x is equal to, so here, the coordinate here is 4 over 5 and 0. Then we have our coordinate here, 4 over 5. So when you're sketching, you just need to put the exact coordinate. And in terms of y, it's negative 4. So we can put our negative 4 here. There's no need for you to put negative 1, negative 2. Then here we just connect with a straight line. Okay, that's our sketch. So then we label our graph. Y is equal to 5x minus 4. Okay, now when you look at the domain is going to be, domain for linear functions is x element of real numbers. Okay, because in our domain, you're looking at the x values. So it's element of real numbers. Then for the range, it's y also element of real numbers. Okay, then in terms of the maximum, doesn't have a maximum. A minimum doesn't have a minimum because it goes up until infinity. Then when it comes to increasing and decreasing, our function here is increasing. So in this case, it's increasing. So in terms of, we're going to say increasing. Why increasing? Because our gradient is positive. So when the gradient here is positive, when m is positive, then it means that it's increasing. So it's increasing for y, for x element of real numbers. Because it's increasing, or you can put it this way, you can say x negative infinity. It's x element of negative infinity to infinity. Then we are done like that, okay? So that's our first question here. And I think I will leave it here. Thank you.